So again, y is my, c is my y-intercept. I should write that better because I couldn't even read that as I looked at it. It's my y-intercept. So let me just remind you of some things. So what are some functions we've had? We've had linear, right? Y equals m. Let me do this. Y equals m x plus b. So here, y and x are my variables. My constants are m and b. There's some number you got to find to figure out what your linear equation is. Right? If we figure out what m and b are, we have our linear equation. This is the one you folks are most familiar with. Right? So it might be something like, example would be y equals 3x minus 4, something like that, right? And then we have quadratic. We have something like y equals x squared and an x. So it might be like it's ax squared plus bx plus c. Remember that one?
Yeah.
And again, here my constants are a, b, and c. There's some numbers I need to find, and then I'm kind of all good. Or they're given to me often.
Like constant. To me, that says that they don't change.
They don't change, exactly. They don't change. They're constant. So for this problem, it might be 3x squared minus 2x plus 1. So these numbers for this equation, they're fixed. The things that vary, the things that change, are y and x and y. X and y are my variables. They're the things that vary.
Okay.
So x will change, and as x changes, y changes. Or y will change, and as y changes, x changes. So if I go back to my... Yeah. If I go back to my... Oops. This guy over here, what's changing as I go through here are my x and my y. See, x comma y changes. My point changes.
We're not seeing
We're not
anything.
seeing it.
Whatever you're doing, we're not seeing it.
Okay. Sorry. Let's try that.
Okay. There we go.
So as I go along here, thank you, my x and my y are what's changing.
But one's controlled and the other's not.
Well, one changes the other one. So, like, theoretically, my x determines what my y is. But you could flip it the other way. And I can say, well, what's y? When y is 6, what's x? Oh, it looks like it's right here. When y is 6, x is, well, it's almost negative 2.5.
It's dependent on each other when they change, right?
Yeah, they change with each other.
Yeah.
As one changes, the other one changes. But you'll see over here, my 2's, those are the constants. If you look over to the right, and we see these folks off to the right. Those, the 2x, the x to the second, 2 to the x, those are my constants. 2 is my constant. So that's what we're looking at. Once you find out what the constant is, then you have the equation. So here my constants for quadratic are a, b, and c. Oops. And then for this exponential, we have, we can even look at the variations, right? We have direct, so that's y, my variable, equals k, my constant, times x. So again, k is my constant. So for example, it might be like y equals, I don't know, 3301x, I think was one of our problems, something like that, right? 3303x was one of our, something like that, I can't remember. And then we have indirect variation, where we have something like what was it, y equals like 550 over x, something like that. So x and y are my variables. K is just some constant I need to find. So here it was like y, again, y is my variable. My k is the thing that I'm trying to find. But y and x are always here in all these problems. There's always going to be a y and an x. Those stay fixed. Right? Those are the things that, I shouldn't say stay fixed. That totally is the wrong word. Those are the things that are always going to be the letters, the variables, because those are the things that change, that aren't constant. So once I figure out what my k is, boom, boom, then I have my equation. So this, all these red things, those are some number, we call them constants, that we need to find to figure out what our actual equation is. Our x and our y are always present as x and y, because those are the things that, those are our variables. They will change from minute to minute, right? As we go along the line, my x's change and my y's change. So I wanted to impress upon you that idea that my x and my y, they're always going to be x and y, always, because they're variables. These other things, these other letters, those are what we call constants. Our goal is to find out what they are, so then we have our equation.
Even though they may change the letter for the x and the y, right? To it's another letter.
Yeah,
sometimes.
right.
It's
Sometimes,
not always going to be like x and y.
Right.
Right.
So think of them as x and y, even though sometimes we call it time and distance, right? Time is really your x, distance is really your y.
Right, they'll put t and d in there or something.
Exactly.
Yeah, okay.
Exactly. So for ours, now what we're looking at is that we have, this is exponential. So we have y equals c times a to the x. So c is a constant we need to find. A is another one we need to find. But y and x are always going to be y and x. So we need to find c and a. If we find c and a, we have our problem. You know, for an example, might be like y equals, the last one we had, 1 times 2 to the x. That was the one we just had just a second ago, right? So here's c and a. Those are my constants we need to find. So once you find c and a, plug them in, you're good to go.
They usually give you c and a in the problem? In the word
Yes.
problem? Yeah.
So we will often give you c and a. Sometimes you need to find them, but you're always. That's what we're going to explore. That's what we're exploring right now. That's a great question. So here, I'm giving you this thing here. What's my c?
2.
Yep, c is 2. Everybody else find my a. Everyone take 3 seconds. 2 times 3 to the x. My c is 2. What's my a? A equals what?
3.
3. Does everyone see that? Okay. A equals 3. Good. All right, so I'm just going to work out a couple of them. So if x is 1, then we have y equals 2 times 3 to the 1. That's my x. Put that in red maybe. So that would be 6. So when x is 1, y is 6. All right, so let's try when x is 2. Y equals 2 times 3 to the second when x is 2. So 3 to the second is 9 times 2. So my y would be 18. When x is 3, y equals 2 times, I'm going to put in parentheses if you like that better, 3 to the x is 3. 3 to the third is 27, times 2 is 54 exactly. Okay, so we just look at the number change. 6 minus 2 is, how much does it increase from 2 to 6?
4.
4. Does everyone understand where we got that from? How about 18, from 6 to 18? What's 18 minus 6?
12.
Yep, perfect. Nice. All right, and then what's 54 minus 18? One's a little bit harder. 36 maybe? Yeah, 36. Okay, good. So does it go up? Is it linear? Does it go up by a constant amount each time by adding a constant amount each time?
No.
Phyllis is like, no. Put a voice to your words, that way we can move on quicker.
No.
Okay, but let's look at the percent change each time, or the factor change each time. What's 6 divided by 2? 3. What's 18 divided by 6?
3.
3, yep. 18 divided by 6 is also 3. Now we're going to put in your calculator, 54 divided by 18.
It's got to be 3.
What do you get? Eric predicts it's going to be 3.
Yeah.
What do you actually get? Someone do it. David, do it for us.
Okay. 3.
3. So our factor change is 3. Why is that? Because what's our A? Our A is 3. So A is also known as our growth factor. Yep. Or our base. All right. So looking at the table, do they grow, do exponentials increase by a constant number or a constant factor? Which one, folks? Factor. Constant factor. Factor being multiplying. Constant number means you just add the same amount or subtract the same amount. So as y grows exponentially for each unit increase in x, that means as x goes up from 1 to 2 or from 4 to 5, y increases by a constant factor. In other words, by multiplying the same number each time. So finding the equation of an exponential function from a graph. So this is you're going to have a couple homeworks on this. It's pretty, homework problems on this. It's pretty helpful because we're going to use two nifty properties of exponents. The first one is any number to the 0 power is what? 1. 7 to the 0 power is 1. 100 to the 0 power is x to the 0 power is 1. So any number to the 0 power is just 1. We're going to use that. The second thing we're going to use is any number to the power of 1 is just that number. So 7 to the 1 power is 7. A million to the 1 power would be a million. Great. So how does that help us? We know that when x is 0, a to the x is what?
1.
1. So does that make sense for folks? Because when x is 0, that's a to the x. Here, I'll write a to the 0, which is 1. Good? When x is 1, a to the x is what?
A.
Yep, it's a to the 1, which is a. So we're going to make use of those two things from our graph here. All right, so first I need to find those 2 points. I need to find when x is 0. So find on here where x is 0. X is 0 along this line here. Does everyone agree with me? Yes?
Yeah.
So where's my point where it hits the graph? Right here. What is that? 3?
0, 3.
Is that right? 3? All right, so we have the point 0, 3. And then where is it? So when x is 0, y is 3. So our ordered pair is 0, 3. Now we can put those into our function. So I'm going to put 0 in for x, and what's going to be my y? 3. So then we know that a to the 0 power is just 1. So 3 equals c times 1, which is just c. So c is 3. So in other words, if you find your y-intercept, whatever y is, that's your c. C is the y-intercept.
C is the y-intercept.
Yeah. Here, I'll do it like this. Does that make sense? Does that make more sense?
Yeah.
So my y-intercept is 0, c. Does that sort of make sense for folks? We talked about that a little bit last class, I think.
Yeah, I'm just lost on how this works down here, this 3 equals c a
Oh.
2.
A to the 0
No, yeah.
is 1.
Yeah, like, how did you get that 3? I mean,
Oh,
is
what-
there a problem with
I
that to get
substituted
that?
in x, 0 in for x, and 3 in for y.
Oh, okay. 0 in for x, 3 in for y.
Yeah. Here, I'll do this. 0 in for x, 3 in for y. Right? This is y. This is x. So, makes sense. Or maybe I'll better write the x here. Okay, well, I'll do this. Like that. Right? That's x comma y, so I put in 3 in for x, 3 in for y, I put 0 in for x, and that's how we get this one. But in the future, you can just know that once you find your y-intercept, that is your c. Done. It's your initial amount. You folks remember initial amounts from before? We had our initial amount, and then we have our growth factor or change factor.
But to find the y-intercept, you have to do the whole graph? You got to graph everything first to find it, or is it getting
No,
given?
so it depends. If you're given, we're just trying to figure out how do you find the equation from a graph.
Oh,
So if you're given a graph, this is how you find the equation.
Okay.
Okay, so now we have to say, okay, so now what happens when x is 1? We need to find another point. So now we have our c. So now we have this right here. We have y equals 3 times a to the x. We know what c is. We found our c. So is everyone following that part? Now we just need to find a. So we can grab any other point from the graph, plug in x and y, and solve for c. So we'll grab the easiest one. What's our, when x is 1, what's our y?
So you can just make up a number, anything?
No, you can't make up a number. Oh, you mean any x?
Yeah,
Yes.
like you just can
You
put
can grab
1, 2,
any point.
any
Yes.
point,
You can
okay.
grab any point. If you,
Okay.
if you wanted, you can grab 1.5, which would be
Okay.
really messy and a pain.
Okay,
I think you should grab ones on the grid marks, because those are the easiest.
okay.
So I'm going to grab this one on the grid mark, because it's 1, 6. So grab one on the grid mark, it makes your life easier. So when x is 1, f of 1, is f of 1 my x or my y?
Y.
It's my y. So when x is 1, y is what? 6.
Yeah.
Right? Because we have the point 1, 6. Is it following okay for people?
Okay.
So now, flip the page. When x is 1, y is 6. The order pair for this is 1, 6. So now we can substitute those in. We can put in x is 1, y is 6. So then we have 6 equals 3 times a to the 1. What's a to the 1?
A.
A. So 6 equals 3a. How do I solve for a? Divide both sides by 3, and I'll get 2. A is 2. So finally, we have our equation. Y equals 3. My C is 3. My A is 2. So my final equation is going to be y equals 3 times a to the x. Done. All right, so now we're going to have you folks do some equations, exercises. Remember your exponential form is y equals c times a to the x. And if you want, you can put little parentheses around the a to the x if it helps you remember to do the a to the x part first. It's up to you. But find your c, and that's going to be your y-intercept. Plug that into your formula, and then plug another point in to find your a. And if you want, you can even plug in if x is 2, you can find out, and y is whatever. You can even do that if you wanted to. It just involves a little bit harder because it involves square rooting. We'll do one more that's kind of together. So we got to look at. It's not showing it very well on there, but I can see it. You can see it well on your paper. Find your 2 points. So find 0 comma something and find 1 comma something. Figure out what those 2 points are. Those are the 2 points you need. So look at your graph and find them. When x is 0, what's your y? They're good marks. Find them along here. Here's where my x is 0. Find it. When x is 1, find it. We can even do when x is 2 if we wanted to. Looks like it's right here. So find your points along there, the grid mark spots. Oh, you need the hand. We're on the back page right now. So what are those points? First one is 0 comma 1. Good. What's the next one? 1 comma what? 3. Good. And we could even use, if we wanted to, we could even use 2 comma 9 if we really wanted to. It's a little bit harder. So that's a possibility. Okay. So when x is 0, what's y?
1.
1. Make sense? So that means that 1 is equal to c times a to the 0. Right? Because we're going to put x is 0. We'll put that in here. Y is 1. We're going to put that in there, right? Because we have, remember our function is y equals, I'll move it up here. We're starting with y equals c times a to the x. So we're putting in 1 in for y, 0 in for x. Right? 0 comma 1. So we're going to put in 1 in for y, 0 in for x. Everybody with me on that part? So then I have 1 equals c times a to the 0 power. What's a to the 0 power? 1. So everyone agree with that? So 1 equals c times 1 is just c. So c is 1. Now if we want, we can skip that step in a way and go straight to c equals 1 because we know that whenever x is 0, my y is my c. Right? C is always going to be whatever my y is when x is 0.
So only when it's 0.
Yeah, only when x is 0. C is my initial amount. We'll talk about that a little bit more next handout, but that's something to keep in mind. So when x is 1, what's my y? X is 1, y is 3. So then that means that, so far here I have y equals 1 times a to the x. So now I'm going to substitute in for y and x. I'm going to substitute in 3 in for y, and what in for x? What's my x? When y is 3, x is 1. So then I'll have 3 equals 1 times a to the x is 1 power. Okay, so a to the 1 power is really what?
Okay,
A. And 1 times a is
still
a, yep. So 3 equals a. A is 3. So now do I have my c? Do I know my c? What's my c? Sorry. C is 1. What's my a? 3. So now I have my function. Y equals c, which is 1, times a, which is 3, to the x. Done. All I'm looking for is trying to find my c and my a. Once I find them, I'm all good. Now, since this is 1, I can rewrite that. I can ignore the 1 in a way, right? Because the 1 is sort of invisible. And I can write it as 3x. 3 to the x, sorry, if I wanted to.
You skip to,
Skip.
on the B, then
Oh,
equals A.
I just wrote it down here instead.
Oh, is that what goes in there? Okay.
Yeah. So that's 3 equals 1 times a to the 1.
Okay.
I just wrote it down below. I thought that'd be easier.
Okay.
Folks to follow. Okay, so you folks do number 2.
So this is different.
It is different, but so you had to find your 0 comma what and your 1 comma what.
Okay.
Find those two numbers and then you're going to plug them in.
Oh, they have it on the graph over there.
Yeah, find it in the graph.